Hello and welcome back to another video. In this one we'll be taking a second order differential equation exercise, which states y double dash plus 5y dash plus 6 is equal to 0. We must find the general solution for the following equation. However, we are giving the boundary condition of y of 0 is equal to 2 and y dash of 0 is equal to 3. So, the first step is to find the general solution. So, the first step is to extract the second degree equation. So we have y double dash gets replaced with r squared plus 5 and y dash is replaced by r plus 6 is equal to 0. Now we have the second degree equation. Now we must find the roots for that equation. Now we're gonna use the quadratic formula. So we have r1 2 is equal to minus b b squared minus 4ac divided by 2a. Now a is equal to 1, b is equal to 5, and c is equal to 6. So we have the following: negative b, which is 5, so negative 5, the square root of b squared, which is 5 squared, minus 4 multiplied by 1 multiplied by 6 divided by 2a. So we have minus 5, the square root, so we have 25, minus 4 times 6 is 24, divided by 2a, or 2 times 1, sorry, so it's just 2. So we have negative 5, the square root of 1 divided by 2. So we are left with r1 is equal to minus 5 plus 1 divided by 2, and r2 is equal to negative 5 minus 1 divided by 2. Let me just move the screen a bit. So r1 is equal to 4 divided by 2, which is equal to negative 4 divided by 2, so we get negative 2, and negative 6 divided by 2, which is negative 3. So now we have r1 and r2. Therefore, we have the following. We have the general solution of y is equal to c1 exponential r1x plus c2 exponential r2x, which gives us c1 exponential of negative 2, because we have r1 is negative 2 x, plus c2 is equal to the exponential of negative 3x. Now, as you can see, we were given the boundary condition of y of 0 is equal to 2. So for every x we have 0. So we have, for the y we have 2 is equal to c1 the exponential of negative 2 multiplied by 0 plus c2 for the exponential of negative 3 multiplied by 0, which would give us 2 is equal to c1, because and the exponential of negative 2 multiplied by 0 is exponential of 0, and anything to the power of 0 is 1. So we have c1 multiplied by 1 plus c2 multiplied by 1. Therefore, we have 2 is equal to C1 plus C2, and that's our first formula. Now, we must find the values of C1 and C2. We have one more boundary condition, which is y dash of 0 is equal to 3. So we take this equation here and derive it to the first derivative. So we have y dash is equal to negative 2 c1 exponential of negative 2x plus c2, sorry, it's negative 3 c2 exponential of negative 3x. Now we substitute the values of the boundary conditions, so we have 3 is equal to negative 2 c1 exponential of 0 minus 3 c2 exponential of 0, and we are left with negative 2 c1 minus 3 c2, and that would be equal to 2, and that's our second formula. Now all we have to do is use the elimination method to find the values of c1 and c2. So we have 2 c1 plus c2, sorry, 2 equal to c1 plus c2, and 3 is equal to negative 2 c1 plus, sorry, negative 3 c2. Now we multiply the first one by 2, therefore we get, I just adjust here, is 2 multiplied by 2 is 4, and we get 2 c2 plus 2 c1, and now we use the elimination method. We have 2 and 2, they cancel out, so we are left with 7 is equal to c2, because negative c2, so we have 2 c2 plus negative 3 c2, we have negative c2, so c2 is equal to negative 7, and since we have the value of c2, we can substitute it back into any equation here. So let's substitute it back into equation 1. So we have 2 is equal to c1 minus 7, so c1 is equal to 9, and now we substitute it back into our general solution. So y is equal to 9 exponential negative 2x plus, sorry, let me change that, minus 7 exponential negative 3x, and that's the final answer. Thank you for watching. Like if you enjoyed, don't forget to subscribe and share if it's helpful. Thank you.